Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello and welcome back with us in Physics Laboratory, School of Electrical Engineering, Telkom University. Today we're going to talk about a new module, which is charging and discharging of capacitors, or we usually call it KP, okay, in Indonesian. As usual, there are 5 outlines that we're going through this practicum. So let's go to the objectives first. So this module divided into 2 submodules, which are charging of capacitors and discharging of capacitors. On the first objectives, which is charging of capacitors, the objectives are to understand the characteristic of charging of capacitor, and the second one is to understand the effect of R or resistor and C capacitor components on the process charging of capacitor. On the discharging one is similar, but the capacitor will be the discharging one as well, okay? So the first one is to understand the characteristic of discharging of capacitor, and the second one is to understand the effect of R and C component on the process discharging of a capacitor. Okay, let's go to the basic theory next. So here on the screen you can see that this symbol is represent a capacitor. Capacitor is an electronic component that have the ability to store the charge and remove it back when necessary. So we know from this definition that capacitor's function is to store the charge, just like a bowl that can be filled by water, and we can use it when necessary, anytime, whenever we want to use the capacitor, okay? On this equation, you can see that C here, C, and in this C, this C is stand for capacitance of capacitor, with the unit to measure the value is called by farad, with an F here, okay? And the Q is stand for amount of charge inside the capacitor, and the unit to measure the value is called by coulomb, or C in here, okay? And the last one is V. Of course, we all knew that symbol, right? This unit to measure is called by voltage or volt. Next, there are 2 different equations for the discharging and discharging capacitor. For the charging one, there is a number 1 here, minus by exponent power to minus time per R times C. On the other hand, the equation for discharging capacitor, there's no numbers before the exponent, okay? So that's the difference between this equation. Now let's give an example for these equations, okay? Take a look at the charging of capacitors equation here first. Now let's change the time here, the T, time of charging process. Let's change the time value by 0 first, okay? Normally, if we want to charge the empty capacitor, the VC or source voltage will be 0 too, right? Of course, logically, if our phone's battery is out of use, after we plug the charger into the phone, it will start from 0% too, right? It's the same for this one. So let's do the equation, shall we? Whenever 0 divided by any numbers, the result will be 0 too, right? So, and here is minus 0 will be 0 because there's no such thing called negative 0, right? And the exponent powered to 0 will be 1 because the law from the second calculus before, if you guys still remember it, the exponent powered to 0 will be 1. So the rest is pretty simple. 1 minus by 1 will be 0, and the E0 times 0 will be 0, correct? That's why whenever you want to charge a capacitor or anything that can store charge will be 0 from 0 second. The second one, discharging capacitors, is pretty much the same as before. If we change the time into 0, the case will be the same. The exponent powered to 0 will be 1, and the E0 times by 1 will be E0 itself, which means if we discharge the capacitors on the 0 seconds, the values will be E0 itself as whenever the capacitor has been used, okay? Now let's go to the tools outline. Tools for charging and discharging of capacitors are the same, okay? So those two submodules will be use the same tools. The first one, there is socket grid, there is digital multimeter, there is resistor, and the values will be 100 kilo ohm. There is DC power supply, so we're going to use DC current here, direct current, sorry. And the next one is capacitor. We're going to use two different capacitor, which are 100 microfarad and 470 microfarad, okay? The next one is stopwatch, and the last one is jumper cable. Now, before we go to the data processing, let's go to the procedure first. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Today, we're going to do a practicum of charging and discharging of capacitors module, or KP in Indonesia. This module itself divided into two submodules, which are the charging and the discharging, just like I said before. We're going to do the first submodule, which is the charging one. The tools and equipment that we have for the module are all the same. Consists of a resistor that has 100 kilo ohm. There is a capacitor that has 100 microfarad with a maximum capacity of 16 volts. The third one, there is a larger capacitor that has 470 microfarad with 25 maximum capacity. The fourth one, multimeter. The fifth one is power supply, but we're just going to use the DC current. There is jumper cable, and the last one is a socket grid. For the first submodule, we are assigned to make a circuit and charge the capacitor. The first step is we have to check if the capacitor charged or not by connecting it with the multimeter. The multimeter itself has to be in the fault area, and then we plug it in here. it's too short. Let's try this. Okay, let's check it out if there's a voltage or not. Okay, wait. Okay, it's empty. Let's check the second one. It's empty too. Now we can make a circuit out of it. The first circuit, we have to use a resistor 100 kilo ohm and a capacitor 100 microfarad. We plug them in here. Okay, here. Then we connect the power supply with the resistor first. Plug it in here. Remember that a capacitor has a polar, so it will have a negative or positive side. So we have to plug it in with the positive side first. Okay, wait. Is it ready? Not yet. After that, we have to calculate the charging speed. So, how to calculate the charging speed? We have to calculate the charge in the capacitor by using this multimeter. How to connect the wire to find out the voltage values? By connecting the multimeter parallelly with the capacitor. Let's find out. We plug it in first here. We use the stopwatch to find out the time variable. We're going to start the practicum, okay? So I'm going to tell the data per 10 seconds until 40 seconds. 1, 2, 3. The first 10 seconds we get 3.83 volt. Remember it, okay? On the 20 second we get 5.43 volt. On the 30 second we get 6 volt. On the last 40 second we get 6.28 volt. What a coincidence! I pressed the stopwatch button at 40 seconds without any millisecond. Now we turn it off. Go ahead, you can write the data from now. If you can't hear it, you can rewind the video, okay? Okay, that's the single series. Now let's find out the series capacitor. Okay, wait. Plug it first. Here it is. You just add one more capacitor, 470 microfarad, and this one is 16. And then the multimeter has to calculate the voltage in these two capacitors. So we plug in 16 volt first and 470 microfarad. Well, we can start it over again to charge the capacitor. Okay, wait. 1, 2, 3. The first 10 seconds we get 1.68 volt. On the 20 seconds we get 3.79 volt. On the 30 seconds we get 5.43 volt. On the last 40 seconds, we get 6.05 volt. You can analyze it later. Now we discharge it again. Okay, now we move to the parallel circuit. It's pretty easy. We can move it. We just move it like this. And then let's start it. Okay, 1, 2, 3. The first 10 seconds, we get 0.83 volt. On the 20 seconds, we get 1.66 volt. 1.66. On the 30 seconds, we get 2.43 volt. On the last 40 seconds, we get 3.03 volt. For this first submodule, the things that you all have to analyze are: 1. Why we have to use the DC current to charge the capacitor. 2. From the 3 circuits, which are this single series, 2 series, and then 2 parallel. Now, which one is the fastest charging and why? Explain it. Here we're going to do the discharging capacitor submodule. First, we're going to start the single series, which is 100 microfarad and the capacitor 16 volt. Here it has charged with 6.30. Right, let's just assume it 6.30 volt. Now I'm going to discharge it. Just like before, I'm going to count per 10 seconds again. So starting from now. Okay. The 0 second, we get 6.30 volt. 1, 2, 3. The 10 second, we get 2.23 volt. On the 20 second, we get 1.11 volt. On the 30 second, we get 0.43 volt. On the last 40 second, we get 0.19 volt. 0.19. Okay, now you got all the data. If you can't hear it very clear, you can rewind it again. Right, now we move to the double series. So it has charged with 6.43 volt. I'm going to discharge it. Go ahead, write down the data of 0 second just by 6.40 volt. It's okay. Let's start to discharge it from 1, 2, 3. Okay. On the 10 second, we get 2.23 volt. 2.23, okay. On the 20 second, we get 0.70 volt. On the 30 second, we get 0.31 volt. On the last 40 second, we get 0.1 volt or 0.10 volt. Okay, right, now we move to the 2 parallel. As you can see here, it has charged with 5.64 volt. on the 0 second. I'm going to start the timer, okay? 1, 2, 3. On the 10 second, we get 4.65 volt. On the 20 second, we get 4.04 volt. On the 30 second, we get 3.40 volt. On the 40 seconds, we get 2.91 volt. Okay, for this second submodule, the things that you will have to analyze are: 1. In this discharging submodule, why we have to use a resistor. 2. And when discharging happens, why we have to do a short circuit. Why we have to short the circuit when we want to discharge the capacitor. Okay, well, that's all for today's practicum. You all can analyze the 2 questions that I have assigned you from now. Each submodule has 2 questions, and thank you guys for watching. I'm sorry if I missed something. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon.